Welcome to qnawire.
So I want to graph the function y equals 4 times x on the interval 0 to 2. So on the interval 0 to 2, at 0 the function is 2, at 2 the function is 8. So that's going to look like this. And if I want to find that region under the curve, then I'm just going to drop this segment. So what I'm looking for is this area, right? That exact area. So that is a triangle, and the area is half base times height. So that base and height happen right here where the right angle forms. So half, my base is 2. Now I need my height. My height is the value of the function when I put in 2, so my height is 8. So that is going to give me half of 2 is 1. That's going to be 8 square units. So that's my area using geometry. Now I want to use Riemann's sum with 4 subintervals. So 2 minus 0 divided by 4 means that each of my subintervals is going to be a half in length. So if you think about that, you're starting at 0, you're going out to 2, and you want 4 of these. So you want 0.5, 1, and 1.5. Now we want to use a left endpoint. So we want 0, 0.5, 1, and 1.5. F of 0 is 0, f of 0.5 is 2, f of 1 is 4, and f of 1.5 is 6. I'm going to sum those values. So 0 plus 2 plus 4 plus 6, that's 12, and I'm going to multiply that by the width of the interval. So that gives me 6 square units. So that's not a terribly accurate estimation, right? Now in C, I want to do part B, but I want to use 8 intervals. So that's going to be 2 minus 0 over 8. So now my intervals are 0.25 in length. So if I start at 0, then I want to go by 0.25. Okay. And when I'm finding my heights, these are the values I'm using. I'm not using 2. So we already have 0, 0.5, 1, and 1.5. So we need f of 0.25, f of 0.75, f of 1.25, and f of 1.75. So a quarter of 4 is 1. 3/4 of 4 is 3. 1.25 times 4 is 5, and 1.75 times 4 is 7. So to my sum of 12, I have 12 from before, I'm going to add 1 plus 3 plus 5 plus 7. That is going to give me 28. I'm going to multiply that this time by a fourth. So that gives me 7 square units. So you can see that's a better approximation, right? And for D, I'm comparing them, right? So we can say, let's go to this last one for D with more intervals. We get a better approximation, right? The actual area was, let's go back to that. The actual area was 8 square units. And then when n was 4, we got 6 square units. When n was 8, we got 7 square units. So if we keep increasing, so that answer is yes to that last part, that as we get more and more intervals, we get a more and more accurate approximation.